Okay, so last but not least, today, now we're going to go ahead and talk about the geometric random variable. Okay, so remember what the the binomial situation was, right? There were the bins, right? They have to be binary, independent, number of trials set, and they have to have the same probability, right? So go to page 422 and read the red activity there. Is this your lucky day? I want you to read that on your own.
Can we actually do this, Mr. Ron?
Does this sound like a good deal for you guys?
Yes.
So basically, you have to pick the right day, right? So what's the chances of success here? What is the chances of you getting the right day, picking the right day? It's 1 out of 7, right? 1 out of 7, right? Because there's 7 days and you're randomly to pick one, right? Okay. So think about this. So is this a binary situation? Is this a binomial situation? Can anybody tell me that? Is it binomial or not?
No.
Yes. No.
Yes? I hear yes and no.
It's independent and
Yes?
and because it's not like you're pulling out the day and then not
No.
guessing it again.
The probability is the same, right? You're either success or failure, so it's binary. However, the number of trials is not set, right? Because it's possible that I can do this 50 times and still not get it right. It's also possible I can get it right at the very first time, right? So the number of trials not being set is what sets apart the binomial distribution and the geometric solution, okay? That's what is the difference. That's what the difference is here. So this actually activity is not a binomial situation. It is a geometric situation, okay? So let's go to page 422. On the top where there's a green box, or in the middle, I guess. A geometric setting arises when we perform independent trials of the same chance process and record the number of trials it takes to get one success, okay? Because in the lucky day situation, as soon as you get it right, we're done, right? Okay. On each trial, the probability P of success must be the same, which is true, okay? Let's go to page 423. On the top, there's another green definition box there. The number of trials Y that it takes to get a success in a geometric setting is a geometric random variable. The probability distribution of Y is a geometric distribution with a probability of Y of success on any trial. The possible values of Y are 1, 2, 3, and actually go on and on and on and on, right? I mean, theoretically, you could never end, right? You never get it right, okay? So let's go to the middle of page 423. There's a green box there that says the probability of Y equals K. So K times it takes for you to succeed, right? It takes K times to succeed. This is a geometric probability, right? Which means that what? If it took you K times to succeed, how many failures did you have prior to that? So every single one of the ones before had to be a failure, right? So you had failed 1 minus P, K minus 1 times, right? And then on the Kth turn, right, you finally got a success, right, times 1, basically, right? So that is how you calculate the geometric random variable, the geometric problem, the PDF, right? The probability distribution function, right? Okay. So let's see if we can do an example. Let's say we're going to do the lucky day. Let y equals the number of homework problems the class receives. A, find the probability the class receives exactly 10 homework problems as a result of playing the lucky day game. So in other words, we're playing the lucky day game, and this is going to be 10. Right? On the 10th try, we got it correct. Okay, so the probability of failing is what? What's the probability of success, I should say? What's the probability of success here? Probability of success is 1 out of 7, correct? Again, because it's a random guess out of 7, right? So which is your fail 6 out of 7 times, right? So you had 9 failures and then ding, 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 the 1 success, right? So that would be how you would calculate that. B, find y is less than and interpret the value. Okay, so we want to find less than 10. Okay, this would be what? So if I had the same geo CDF, right, I could go what? N, well, actually, I don't know. Hang on a second. So how do I do this? And I could just add them all together, right? 1, 3, all the way through, all the way. So p equal 1 would be the first time I succeeded the very first time. That's 1/7, right? If I had 2, I failed the first time, succeeded the next time. If I was 3, I failed twice, right? And then I succeeded, and then on and on and on until 9th. If I succeeded the 9th time, that means that I had 8 failures, right? So you're adding this all together, okay? Notice the absence. If you compare this to the binomial PDF, what are you missing in the binomial here? You're missing up here, right? You're missing the sorting or the arranging of the successes and the failures, right? Well, the reason you don't have that in a geometric random variable is because you know exactly what's going on. You know exactly, there's nothing to sort because they're all going to be failures until the very last one is going to be a success. So you don't need that N choose R portion of the binomial CDF or PDF, okay? So that's how that works. If you go to page 424, there's a technology center that tells you how to do a GeoMet PDF and a GeoMet CDF. Okay. So the page, go to page 426, and there's a green box there that says if y is a geometric random variable with a probability of success of p on each trial, then its mean or expected value is 1/p. That is the expected number of trials required to get the first success is 1/p, which makes sense, right? Let's talk about the lucky day thing, right? Lucky day thing, if you have a success of 1/7, you would expect to get it right after 7 trials, right? That's where you would success to get it the first trial, the first success. Okay, so it's 1 over that probability. Okay, good. All right, that's it. You're done for the day. I will let you continue to work on the homework.